Man, I hate it here in...
Yeah, I wish we could find a way to escape or something. Wait, what if we built a hot air balloon to escape, you know?
Okay. Oh man, the balloon's finally complete.
Yeah, now we can finally escape. Oh wait, what's over there?
Wait, what? What are you talking about? Bruh.
Ha ha ha. Now I could escape on my own while you rot and
Alright, that's it. Pocket rock. Pause. Rewind. Now, I don't know how many of you actually caught it, but right at this moment, the balloon started falling. You see, now that raises two questions, of course. The first one being, why does the balloon immediately go into free fall when a hole opens up in the side of it? Second question, what is the rate of change in the angle of elevation between Andre and the balloon as the balloon falls, assuming the only force acting upon the balloon is gravity? Let's look at the measurements. So, the balloon is 727 meters away from Andre at this point, and 314 meters above the ground. Now we know that the rate of change of the height of the balloon is negative 9.81 t meters per second. So let's try to find d theta dt at t equals 2 seconds. Let's actually see if you can solve it for yourself. Here, I'll give you 1/60 seconds. Alright, you done? Too bad, let's go. So our first step is going to be finding the initial angle theta. Now how we're going to do this is we're going to take the inverse tangent of the height of the balloon and the distance of the balloon from Andre. Once we throw that in the calculator, we see that the initial angle is 0.4077 radians. Yeah, we're doing it in radians, okay? Next, we're going to set up an equation that allows us to plug in all of our known values. What that's going to be in this case is tangent theta equals the height of the balloon over the distance of the balloon from Andre. Now, we do have a constant here, and that's going to be the horizontal distance of the balloon, because it's not changing. Now, in order to incorporate a d theta dt term in there, we're going to have to differentiate both sides of this equation. Now, after we do that, we get d theta dt times secant squared theta equals 727 dh dt all over 727 squared. Now, as you can see, we have a 727 on top and bottom, so we could just cancel those out and we have dh dt over 727. Now to solve for d theta dt, we can divide secant squared theta on both sides, and that leaves us with d theta dt equals dh dt over 727 secant squared theta. All we really have to do now is find dh dt, and to do that we plug in 2 to negative 9.81 t and we get negative 19.62 meters per second. And now we can plug our known values into the equation, and doing a proof by calculator we can see that the rate of change of the angle of elevation is negative 0.023 radians per second. And there we have it, the rate of change of the angle of elevation as both Loreen and the balloon fall to their demise. Thank you guys for watching, and I would like to say that Turkey is overrated.